had an argument with a 90-degree angle. It turns out it was right. Get it? Because 90 degrees, it's a right angle. Okay, so like we just talked about with those additive and multiplicative, sorry, that word's tough to say sometimes, multiplicative relationships from the Venn diagram, just to recap it again one more time, make sure that we really get this set in our heads, that for an additive relationship, our equation is going to be in the form y equals x plus some number b. Y equals x plus some number b. It does not go through the origin. Make sure you're spelling origin correctly. O-R-I-G-I-N. Kind of weird. Like we said, it's found by adding or subtracting. Your equation could also be y equals x minus b. It just moves it above or below the origin. That's what the b does. So for example, our graph would look something like this. Yay! Yours doesn't have to be that exact one. Just make sure it doesn't go through the origin. That's an additive relationship. And then the multiplicative relationship, remember, is y equals mx. And they're side by side, that means I'm multiplying. And they're side by side like that, that means I'm multiplying. It does go through the origin. Multiplicative relationships go through the origin, and it's found by multiplying or dividing. So again, it doesn't matter if your graph looks exactly like mine or not. The biggest thing is that it goes through the origin. Your equation can be y equals m times x, or it could be y equals x divided by m. Either one of those works. You typically see mx instead of a division, but it is possible to see the division. Sometimes you'll see the division written as a fraction in that form. We'll see lots of different things as we're working through this unit. The independent variable. The independent variable, think about science class. The independent variable is the value of a known value, and it's represented on the x-axis. That's like my input. I already know what that number is going to be. The dependent variable changes based on my independent variable. It is the unknown variable, and it's represented on the y-axis. If I'm solving an equation, I don't know what my y is to start, but I know what my x is. I know what my x is. So again, the dependent variable y is changed by the independent variable, which is the x. Remember, on your axis, the x is the horizontal axis, and the y is the vertical axis. X is on the sides, y is on the vertical side. All right, we're going to pause the video. Let us know if you have any questions. Otherwise, we're going to keep on keeping on. Two variable relationships can be represented by tables, equations, and graphs. So we have verbal descriptions. One is a proportional relationship, one is an additive relationship. Mrs. Sanchez adds 5 points to everyone's test grade. If I'm adding points onto a test grade, is that additive or multiplicative? Additive. How much is she going to add each on everybody's test? 5. From those words, I think it's easy to come to our equation and say, I'm going to take my test score, my x, and I'm going to add 5 to everybody. My equation is going to be x plus 5. From there, I think it's easy to go to a table, and let's think about test scores. Let's say we've got somebody that gets a 0, somebody that gets a 50, and somebody that gets a 90. The equation tells us, the situation tells us, Mrs. Sanchez is going to add 5 points to everybody's grade. She's going to add 5 points to everybody's grade. So I need to come through, and I know I need to add 5. I need to add 5 to everybody's grade. So if I got 0% on my test, but Mrs. Sanchez helps me out, I would get a 5%. If I scored a 50, Mrs. Sanchez helps me out. She adds 5 points. That's going to give me 55%. I get a 90 on my test. Miss Sanchez helps me out. She's going to add 5 points. That means I'm going to get a 95% on my test. And then we go through and graph. Remember, these are my x values on the side, or on the bottom. My y values are on the side. My x values are 0 to 90. So I'm going to go by tens. My y values over here. Again, I'm going to go by tens. Remember, my origin is 0. So my first point is 0, 5. So on my x, I need 0. I go up 5, so that's like halfway through. And I've got my first dot. Then I've got 50, 55. The x, remember, that's how far left or right you go. Y is how far up and down you go. I tell my students, you gotta slide, pop. Pop, those points don't stop. Hey, don't stop. Hey, don't stop. It's like juju on the beat. So I slide 50, and I'm gonna pop up 55. I slide 90, I pop up 95. And then if you have a ruler, you can use a ruler, but if you don't have one, that's okay. Just try your best to connect the dots to make your line for your graph. Yay! What type of relationship is this? Additive, or is this multiplicative? It's additive. And what was that other word that we used on the Venn diagram? It is non-proportional. Non-proportional. All right. Let's go up to our next situation, do the same thing. Carly earns $7.25 for every hour she babysits. Every hour. Is this going to be additive or multiplicative? It's multiplicative. We're going to take $7.25 times X, however many hours that she's going to babysit. What word up there told you was going to be multiplicative? That word every. Every hour. Every, each. Words like that means multiply because I'm doing it over and over and over and over and over again. If it's the same number over and over and over and over again, I'm going to multiply it by how many times I do it. If I'm only doing it one time, like Mrs. Sanchez, she's only adding 5 points one time, that's going to tell you it's an additive relationship. So depending on how many hours she works, we need to figure out how much money she's going to have. So let's say she doesn't work any hours, she works 5 hours, and then she's going to work 10 hours of babysitting. Again, this is multiplicative because she's getting that $7.25 over and over and over and over again. So I need to take my X values, I need to take them times $7.25. So let me grab my handy dandy calculator. I feel like I'm on Blue's Clues every time I say that. My handy dandy notebook. All right, so I've got $7.25 times 0. What's 0 times 7.25? 0. Anything times 0 is 0. My next one, I'm going to take 5 hours that she worked times $7.25. So she's going to get $36.25. And then the next time, she's going to work 10 hours. 10 hours times $7.25. And she's going to get $72.50. Yay! Again, we're going to go through and graph these things. So on the bottom, I see that I've got 10 lines and I've got 10 hours, so that's going to be perfect. I'm going to go by twos when I'm labeling. Each line represents 1 hour, but I'm not going to write all those numbers down there because ain't nobody got time for that. Those are my X values. And then for my Y's, I need to be able to go up to $72.50. Again, I think I'm just going to go by tens just because I think that's easiest. But I'm only going to write every 40. Oh my goodness, Jackal, you're fine, buddy. He's so whiny. He doesn't want to get up to get water. So my first value, remember, I got to slide and pop. Pop those points on stop. So my origin 0. Oh, I'm not sliding anywhere. Ooh, I'm not popping anywhere. I'm going through the origin. I'm going through the origin because I have that point 0, 0. Then I've got 5 and 36.25. I slide 5. I pop $36.25. Boom, I've got a dot there. And then number 10. Slide 10. And I pop $72.50. So right about there. I've got my points. I've got my ruler. I'm going to connect my dots. And I've got my graph. Again, like we said, we didn't slide, we didn't pop, we stayed through the origin. If we go through the origin, that means it's multiplicative. If it's multiplicative, it's also proportional. It's also proportional. All right, we're going to do the last few problems on the other side in groups. In groups, if we have a co-teacher. If we don't have a co-teacher, we're going to try them on our own, okay? So good luck to you. Let us know what questions you have. You got this.